The tap operator is a pipeable utility operator that really lives up to its name because it's useful not only in helping us to code our applications, but also to debug our applications. Looking at its official documentation, we see that the tap operator is a pipeable operator. We see the operator badge, and its return type is an object of monotype operator function. And the tap operator is used to perform side effects for notifications from the source observable. Exactly what is a side effect? A side effect performs some function, but that function has absolutely no impact on the returned values or the return observable. Looking at the marble diagram for the tap operator, we see that it looks different than any of the other marble diagrams we've seen thus far. In particular, each part of the return observable, and that includes the timeline arrow, the completion notification, and all of the emitted values, they're all outlined in blue. And that's a visual cue for us to let us know that the tap operator creates a return observable that mirrors the source observable. That is, all of the next notifications, all of the emitted values, the complete notifications, and the timing of the emitted values, they're exactly the same as those in the source observable. In the example of the marble diagram, the tap operator is passed a single parameter, and that parameter is a function. The function takes each emitted value and console logs each of those values. And this type of function is known as a side effect because it has no impact on the emitted value. It performs some sort of process, but that process in no way changes the emitted value. And we often see this usage of the tap operator, where the tap operator is passed a single function that performs a side effect on each emitted value. But in actuality, the tap operator is much more powerful than that. If we go back to the intro section of the tap operator, notice that the tap operator, besides taking a function as a parameter, it also takes a partial tap observer. And tap observer sounds like something we've already encountered in the observable primer, and that's the observer interface. It sounds like the observer interface because the tap observer extends the observer interface. Notice that the tap observer interface has the callbacks for next, error, and complete, which it gets from the observer interface, but it has additional callbacks for subscribe, unsubscribe, and finalize. And this means that we can pass a tap observer object which performs different side effects for next, error, and complete notifications, as well as when the observable is subscribed to, when its subscription is unsubscribed, and when the observable finalizes. And if you remember from the observables primer, finalization occurs when the observable either errors or completes, or when a subscriber to the observable unsubscribes. And this makes the tap operator very powerful indeed. Let's go to the course application and fully explore the tap operator. In this coding session, we'll use the tap operator to do some things we've not been able to do until this point. First, if you've noticed in all of the other coding sessions, in order to console log information about the emitted values of an observable, I've been using the subscribe method. Now, using the tap operator, we can console log things within our pipelines. In this lesson, we'll also use the tap operator to discover some things about the operators that we've learned until this point. First, we'll take a look at all of the actions that an HTTP client method goes through once it's subscribed to. And if you remember, our all customers observable on our API service is derived using an HTTP GET method call. So I've set up the tap operator in the pipeline, and I've added a tap observer which logs out statements and values when the observable emits, completes, or errors. And of course, those callbacks are inherited from the observer interface. I've also added callbacks for subscribe, unsubscribe, and finalize, which we get from the tap observer. Now, one thing you might be wondering is if finalization occurs when either the observable completes or errors, or when a subscriber unsubscribes, if there are already callbacks for completion, erroring, and unsubscribing, why would we need one for finalize as well? Having separate callbacks for completing, erroring, unsubscribing, and finalizing allows us to set up different side effects for completing, erroring, and unsubscribing. And then we can use the finalize to perform still another side effect, which occurs when either of those actions takes place. So actually, this makes the tap operator even more powerful. Now that we have our tap operator in place and it's logging out statements for all of our observable notifications, as well as for subscribing, unsubscribing, and finalization. Now that we have that in place, let's take a look at what's logged out for the all customers observable. So we see that we get a subscribe log statement, and that occurs when the async pipe subscribes to the observable. Then we get an emitted statement, and we see all of the values. We see the entire array that the all customers observable emits. And then we see a completed statement and a finalized statement. And that's because the HTTP client methods, once subscribed to, they either emit their values and complete or error. And we see the finalized statement because completion has occurred. Now, if we navigate away from this page, the async pipe should unsubscribe to the all customers observable, and we should see an unsubscribe statement, right? So let's navigate away. Let's navigate to the home page. We don't see an unsubscribe statement. Why is that? Well, that's to be expected because completing, erroring, and unsubscribing, they are all mutually exclusive. And observable either completes or errors, or the subscriber unsubscribes. You can only have one of those things occur. And once completion, erroring, or unsubscribing has taken place, we then also get a finalization, which is why we see the finalized statement. So this is one of the powers of the tap operator. It really helps us to understand all of the properties of observables. Now that the tap operator has shown us how the HTTP client methods behave, let's investigate how the interval operator behaves. Remember, the interval operator creates an infinite observable. So let's change the all customers observable to an interval that emits every 1.5 seconds. And now let's take a look at the console. And we see the observable is subscribed to via the async pipe. And then it just continually emits. We don't see any completion notification. We don't see any error notification. We don't see any finalization notification. But if I navigate away from this page, We then get an unsubscribe because the async pipe, once we navigate away from the page and the component is destroyed, the async pipe unsubscribes to its observable. And of course, when unsubscription occurs, we also get finalization. Now let's take a look at how the tap operator helps us with our day-to-day coding tasks. And let's say, I've just started my workday and I'm investigating what's occurring with this service. I've been assigned a task to change what's being displayed, but I want to know what's occurring in this current version of the service. And first of all, I want to know what these map operators are doing to the output of the all customers observable. And that's where the tap operator comes in. I can place a tap operator between the source observable and the first map operator and console log the original array that's emitted from the all customers observable. And then I can place a tap operator between the two map operators to see the state of the array after get age has been applied. And lastly, I can place a tap operator after the last map operator to see the state of the observable after the sort has been applied. So now when we take a look at the console log, we see what the original array looks like after it's been emitted from all customers. And notice there is no age property on any of the customer objects. Then after get age has been applied, we see that now we do indeed have an age property and value in each of the customer objects. But notice that the customers are not yet sorted by last name. However, in the tap operator's console log that's placed after the sort, the map operator that does the sorting, we see that all of the customers are indeed sorted by last name. So this is how we use the tap operator during a typical coding day. It helps us to parse and understand what's going on in our pipelines. Throughout the rest of the course, we'll be using the tap operator in this manner a great deal, but we'll also begin using the tap operator in other ways, mainly to affect change in our reactive programs. And that will come when we begin to create more complex user interfaces.